Our last objective in section 1.8 is to translate English into mathematical expressions. And we practice this because you're going to need this ability in order to be able to solve applied problems, or you often refer to them as the dreaded story problems. But those are really the only kinds of problems that exist in math outside of a math classroom. So it's really important that we build some skills that will let you figure out how to tackle a story problem. So the first suggestion, or the first step, would be to read the problem and make notes. Okay, and by notes, make notes. There we go. And by notes, I mean jotting down to yourself anytime you see something that looks like a number or an operation. Remember, operations are things like add, subtract, multiply, divide. Okay. Since our expressions are going to be algebraic expressions, you're going to need to choose a variable to represent the unknown. Okay, because there will be something in each of the ones that we're looking at that's a value or an amount that we don't know. In these first ones, we're probably going to be using x or n. Those are the most common ones that are used when we're just using English words. When we get into application problems, you might choose a variable that represents the actual item that you're talking about. So you may have heard of the formula E equals mc squared. And as you see, there aren't any x's or n's in that, but they chose E because it stands for energy, and they chose M because it stands for mass. So those letters make sense. And then C stands for the speed of light. Not really sure why that's a C. I'll have to look that up and see if I can find out. So choose your variables, the next step. The third step then is to translate the phrase into a mathematical expression. So let's do some examples. So when I'm reading this, I'm going to read it really slowly and I'm going to make notes as I go. The first word I come to is the word 12. So I'm going to make a note that when I go to write this as my mathematical expression, I'm not going to spell out the word 12, I'm going to use the digits 12. The piece less than means that I'm going to be taking something away from the 12, and we use subtraction to do that. Twice means to double something or to take two of it. So twice is going to be 2, and then the words a number are the thing I don't know. It's some random number, they're not telling me what it is. So I'm going to choose a variable to represent that unknown, and I think since they have the words a number, I'll pick n to represent my variable. So the only thing that's left to do in order to translate this into a mathematical expression seems like it would be to just take this phrase and copy it down just as it is. 12 minus 2n. But that would actually be incorrect. Because if we go back and look at it again, it's telling us that we want to take the 12 away from the twice a number. We want 12 less than whatever we get for twice this number. Okay? So that's why I chose this one as one of our examples, because it's one of the ones that's a little bit tricky. When you see this less than phrase, you're going to take whatever the number is that's in front of it and move those to the end. So we have to figure out what our two ends are first. Take a number and find twice it, or double, and then take the 12 away from it. Okay? And that's really important with the less than, because subtraction is not commutative. If we switch these two terms in the opposite order, we wouldn't get the same result once we knew what n was. Okay. Looking at number 17, I'm going to go through and make my notes again. The sum, so a sum is addition of, here's my a number, so that's going to be my letter n. So I'm taking the sum of a number and 6 that's getting times, multiplied by that same number. Well, since they've told me that the number here is the same as the number there, I'm going to use the same variable to represent it. So I'm going to represent same number with an n also. And then they're telling me that they want me to take that number and sum it, add it, to 6 times that same number. So when I go to write this down as my expression, I'm going to have the n, and then the sum of what it is that's getting summed. In this case, the things that are getting summed are my n and my 6n. So it's going to be n plus 6n. The next one starts with a 4, and the 4 is getting multiplied by a number that then gets divided by 7. So to write my 4 times a number, I'm going to write 4n. Remember, the multiplication's implied. If you have a number next to a letter, you already know that multiplication's what's happening. And then I'm going to take that and divide it by 7. And when we write division in an algebraic expression, you won't very often see that symbol. Usually division is represented with the fraction bar. Our final one starts off like the one up here, that we're going to take two things and sum them together. Well, what are the two things that we're adding? It looks like we're going to add a number, that's our n, and we're going to take it and add it to a 10. And then we're going to divide that sum by 2. Okay? And this one says it's not just the 10 that's getting divided by 2, because if we wrote this as n plus 10 divide 2, order of operations would make us take the 10 and divide it by 2 before we could add the n. And that's not what the instructions has asked us to do. They want us to find the sum first and then do the division by 10. So that means I'm going to need to write this as n plus 10, and then after you've figured out the answer to that, take the whole thing and divide it by 2.